Hi everybody. So this is my first Twitch live stream. There's nobody actually watching. What I'm going to be doing over the next little while is teaching myself Rust, the programming language. And I'm going to do that because, I don't know, just it's an interesting thing to do. And it's been it's been a while since I've learned a new programming language. So, it's time to do that again. Just a little bit about myself. I am been in the software development business since January of 1979 is the first time I actually got paid to write some software. It was a co-op position. I went to the University of Waterloo for engineering, and honestly, back then there was no such thing as computer engineering, or really there was computer science, sort of, but I did an engineering program and kind of taught myself to code. We did Z80 assembly language and 6502 and mostly assembly language stuff. I taught myself C back then there was a two-stage compiler. The first stage would take your source code and turn it into assembly language, and then the second stage would turn it into object code that could be run, binary. And I would look at the intermediate stage, look at the assembly language, and try things out in the C language and see what they did in assembly. And that's how I taught myself what all the different symbols did. So, since then, I've kind of did embedded systems, and I did mobile devices. I've done code on Android, Windows systems, embedded systems, and over time, I've kind of drifted towards, like we all have, the whole industry has, into managed languages, so C#, Java, and it's been a boon to do that because when I was writing in C on the Palm Pilot and the original Windows CE mobile devices, I would say that like 90% of our bugs were buffer overflows. And so getting out of that, having C# or Java manage that on your behalf was amazing because suddenly 90% of my bugs went away. And I had way less debugging to do and work to do, and it was much easier to find bugs because those buffer overflow things are very nasty to try to debug because you overflow a buffer here and the results of that appear there, and there's no necessarily correlation between here and there. So what's interested me in Rust is that I can get back to doing, or I think, according to this, I can get back to doing C-type code, but the compiler is going to enforce some rules around memory reallocation and freeing and that sort of thing. And that sounds like a really interesting idea. So I thought, hey, why not? This looks like a language I'd like to learn. Drop me back into the old days where I was doing more direct to the metal kinds of things. All right, so as you can see in the background here, I've got the Rust language page up, and let's just go have a look and see what it says here. So there's performance, reliability, productivity. Oh yeah, we all, it's always that. Okay, so command line, WebAssembly, networking, embedded. So I think what I'm going to do is I'm going to focus on command line. WebAssembly and, these guys are kind of cool, and eventually we'll get there, but I think as far as learning a language is concerned, I'd like to start off with something really simple, and a command line is probably as simple as you can get. Okay, so then, fine, let's get started. So what do we have to do? Installing Rust. Sure, let's do that. Well, no, let's not try Rust without installing. Let's download the 64-bit. I'm running I'm running in Windows here. Download Rust Up Init exe. Okay, so let's click on that. There we go, completed. Click. And there we go, proceed with installation. Yeah, I'm not going to customize anything. So off we go. Ta-dum-ta-dum. Okay, so we've got some things it's installing. It's downloading Cargo and Clippy and Rust docs. Oh, okay, so some documentation here. And Rust is installed. Oh, well, that was quick. To get you started, you may need to restart your current shell. Press Enter key to continue. All right. Okay, and then, oh, look, there's, if you want to check to make sure it's up to date, you can run Rust Up Update. So let me just, there we go. So here's my command shell, so Rust Up Update. Okay, checking for updates, 1.65. Yeah, so we're good, we're done. Okay, and oh, by the way, Rust Up works. The command actually did something, so it looks like it's installed correctly. Okay, so then it says build your project with cargo build, run your project with cargo run, test your project with cargo test. Okay, and then to test whether you have cargo installed, cargo -- version. Okay, so let's go back. Did I close that? I think I closed that. That was kind of dumb. All right, so cargo -- version. Okay, 1.65, cool. So that's, again, another proof that it's working. And let's not close it this time, let's just minimize that. Okay, so read the cargo book, other tools. All right, so I like to use Visual Studio Code. Obviously, there's a whole bunch of different choices here. You can do whatever you want, but I'm going to use VSCode. That's the one I'm most familiar with. All right, so let's do that. Let's see what VSCode support we have. Rust Analyzer. Okay, so this is Visual Studio Code, Rust Analyzer. So we need to install that plugin. So let me just, instead of doing it that way, let's go to Visual Studio Code and go to Extensions and search for Rust Analyzer. There it is. So this one. And we want to install that. Okay. And okay, that's installed. And this one, the Rust syntax one, I don't know. What's Rust extension pack? Minimalist, VS Code extension pack for Rust. This includes Rust Analyzer, crates, whatever better, TOML, whatever TOML is. Okay. And all right, so we'll just leave that one alone because this was like kind of an opinionated. This thing, Rust Doc Viewer. What does this thing do for us? View locally generated Rust documentation. Okay. Nah, not yet. I'm not far enough along in this thing to actually create documentation that I'd want to look at. Okay, Rust syntax highlighting. Now this might be interesting. This extension provides a TextMate grammar for Rust. In most cases, you won't need to install the extension. Upstreamed by VS Code. If you're doing a thing on Rust, the semantic highlighting will be superior to a TextMate grammar. Okay, so in fact, it says don't do this. I'm not quite sure why. That seems to imply, hey, if you're doing something, the semantic highlighting provided by Rust Analyzer will be superior to the TextMate grammar. So this, not going to do, because it sounds like Rust Analyzer is going to supersede my Rust syntax. Okay, so just the one thing then. Okay, so there we go. We're there. So let's pop back to the documentation and let's go back. So we've got that one. Now, So we're done installing. So the install thing is all done. Let's go to learn. Okay, so we've got get started with Rust. Read the book. So it's going to be really boring if you are forced to watch me read the book. That's not going to be a lot of fun. Do the Rustlings course. You know what? Check out Rust by example. There we go. I like that one. I'm just going to play around with stuff. I like to learn by playing with it. So let's just play. So we'll do that. And what have we got here? We've got hello world and primitives and custom types and variable binding and all sorts of other things. Okay, so we've got like 24 different lessons, I guess. So sure, that seems like a reasonable thing to do. So let's start with hello world. Okay, so we've got, looks like I can copy, I can run it here, but I can also copy it. And what else does it say? It says, and actually let me just do this because this is a little small. Yeah, that's fine. Okay, so this is saying I can copy that. I can, what's this? Undo changes, so I can put it back. So there's a main function. Oh, it's the typical hello world thing. We can run it. Okay. So this, all right, so this isn't really telling me, so that's not, I don't know how that's going to work with Visual Studio. So let's see if I can find something else. VSCode Rust support. Let's see. Something Visual Studio side. It's going to tell me something. Okay, again, let's make this a little bigger. Make it a little easier to read. Okay, so we've got, okay, install Rust. We did. Install the Rust Analyzer extension. We did. Check your installation. We did, but we used cargo. We got it updated. Sure. All right. Now, cargo. When you install Rust with RustUp, the toolset includes the Rust C compiler, Rust format source code formatter, and Clippy Rust linter. Okay, yes, cargo. We do that. We have cargo. And a good way to create your first Rust program is to use cargo to scaffold a new project by typing cargo new. Okay. All right, let's do that. All right, so back to the command line. Let's go up to the top level of the C drive. I'm going to make dir rust. Change directory rust. So rust is empty. Okay, so at this point, I want to type this cargo new hello world. Now, interestingly, I would have used camel case, but we are using underscore. Let me see what they say. Enable workspace trust. Okay, yeah, whatever. Okay. So it appears as though, I don't know. Anyway, they're using the underscore. So I'm going to use underscore. I'm going to follow their pattern here. So I'm going to say that. Because normally what I would do, I mean, you know, this is from the C# JavaScript world. You would do something like that. So JavaScript, it would be that. C#, it would be that. Looks like in Rust, it's that. Okay, so cool. We'll just follow along with the conventions for now. Cargo new. Oh, okay, created it. So let's take a look at ls again. And now we have a folder, a directory called hello world. So if we change directory to hello world, Oh, and by the way, that was Control Space in Windows PowerShell completes the name for you if you want. And so ls. So we've got a source directory and then a git ignore and a cargo.toml. All right, we'll look at those in a bit. And one more time, change directory source, ls, and we've got a main.rs. Okay, that's pretty standard. I don't know about the rs part. I guess that stands for Rust. But main, back in the old C days, main was, you know, the name you gave to the program or the file that you wanted to have run first, and there would usually be a method in there called main or a function called main that would be the thing that would run. And the compiler would go look for that, and that's where your program would start operating from. Okay, so we've got a directory structure in here. Let me put this away. Okay, cool. Now let's go to back to here, and what I'm going to do is I'm going to put this extension stuff away and file, open folder, and we're going to go to, get to look at my oops, where'd you go? C : Rust. There we go. Hello world. Okay, so let's open that one. Select folder. Okay. Yes, I trust the authors of all files in the thing. Yes, that's because it's me. There we go. Okay, so the U, in case you're not familiar with Git, the U indicates these things are new files. And if you committed this to a Git repository, these would go in. And so we've got a cargo.toml. Let's go look inside what a toml is. So the package name is Hello World, the version, the edition 2021. I don't know what edition means. Dependencies, we have none. Don't show this again for toml files. We have none, and then there's this reference manifest. Okay, more keys in their definitions. Yeah, well, whatever. We don't have to worry about that. So this toml file looks like, if you're familiar with package.json for Java, JavaScript? No, yeah, for Node files, then that's a similar thing, I guess. Although this is not JSON. This is this reminds me of Windows INI files with their angle brackets or square brackets and name value pairs. So kind of a throwback to the old days. But okay, cool. And of course our star of the show is main.rs, which is the file where our code goes. And so if we go in here, we can look at it and go, okay, there's function main print hello world. So we go back to the browser. What are you doing? Back to the browser. We can look and we go, okay, function main bracket bracket, curly brackets, print hello world, curly bracket. Okay, so if you're, so that's exactly what we did here. And this says, hey, to run this, type rust c hello rs. Well, I'm not going to do that. I'm going to use Visual Studio to run that. So let me just pop back over to here. And there's a run right here. So, I mean, geez, I'm going to use that. So let me click on run. Okay, it's opened terminal. Failed to launch, path to shell executable does not exist. Huh. Hello world cargo run. Well, that's interesting. Rust hello world cargo Why is it doing that? Why not just cargo run? Package hello world, bin hello world, terminal process failed. Oh, that's interesting. Run. Let's add a configuration here. Okay, so this is not doing what I want it to do. Install an extension for Rust. Well, that's interesting. Debug? Let's do a debug. Install, okay, here we go. Install code LLDB extension for debugging. Okay, let's do that. All right, code LLDB. Let's see, back to here, back to there, code LLDB, install. Okay. All right. Did I get ahead of myself here? Okay, let's close that one. That's installed. So there's a second extension I need to install, this code LLDB thing. And let's go back to our code now. Where'd you go there? Code and main.rs. And let's click on debug. Could not launch cargo. Okay, what the heck is going on? All right, let's go back and read some more information, because clearly I have jumped the gun and I've missed something. Cargo can also be used to run your Rust project. Right, and we're in Visual Studio Code, yeah. IntelliSense, inlay hints, hover, semantics, syntax, code navigation, linting, quick fixes, refactoring, formatting, debugging. So there we go. We installed that one. Yeah, then it told me, cool. Using Rust Analyzer debug, available in the command palette, Control-Shift-P, run debug code lens in the editor. Let's debug the Hello World program we created earlier. You'll need to set a breakpoint allowing. You need to be able to setting debug allow breakpoints everywhere, which you can find in the settings editor. Okay, let's do that. Actually, let me just see. Before I do that, let me just make sure, because this is an existing thing. Oh, I can set breakpoint. So I don't need to do that. Back to the instructions. Okay, so we've done that one. Okay, and debug code lens. I think I missed a spot here though. What did I miss? Basic debugging support for debug command available in the command palette. Control-Shift-P and run debug code lens in the editor. But I'm already doing that. So what's happened here? What has happened? The next steps. Oh, we're already in next steps. Did I miss something? All right. So let me see. If I say cargo build. All right, let's try that. Let's go back there and try. Because what seems to be happening is cargo, terminal, new terminal, cargo build. Term cargo is not recognized. Okay. Why? But it was. We did that. what has happened. All right, let me go back to the command line. And if I do a cargo build from here, well, it works. So why does it not work? Oh, I think I know what the problem is. I had this running. Before I installed it, let me close this. Let me start it again. And let me run. There we go. It worked. So it would appear that Visual Studio Code is loading the configuration, the path settings and everything in Windows on startup, and then not bothering to... What happened? Did I waved it away? Oh, it went away. That was interesting. I know why. Because we got the update. The October update. I'm so excited. Okay, so if I run hello world, there's my output. Hello world. So anyway, as I was saying, I think what's happening is Visual Studio Code loads itself up, reads the configuration, the settings, and then it never touches them again. What I had done was I had started it up, and then I installed all of Rust, and then with the thing still open, I tried to run things, and then I was getting failures. But as soon as I close it down and reopen it, then everything's fine, because it reloads the configuration, and now it's got cargo in its path, and everybody's happy. Cool. So we're done with that. Mistake made, mistake never to be repeated. Okay, so now that was run. Debug. Okay, so we hit this breakpoint. So now we get this little triangle here. We've got the coloring. We've got this little control panel here for being able to step over, through, and out of, to be able to continue running, and to be able to stop the execution and to restart the execution. And then to shut the whole thing down. So we can just say stop. And so that's so this is, if you're doing debugging. Now this one's kind of boring because there's really nothing we can peek at. No variables we can check or anything. But we do have a call stack here, which we can look and see what things have been called. And you can see there's a bunch of stuff that happens inside of Rust before, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 things that have been started up before we get to the point where it starts to call our code. So all of this stuff is startup stuff that so I guess there must be some kind of runtime environment here that we're using to run Rust. Now the thing is that this, so if we look, this says launching .exe. So typically a .exe file, and let's just stop this and kind of look. So typically with an exe file, where are you hiding this exe file? Target, probably. No, debug? Yeah. There it is. Hello world.exe. So this is binary. We can't open it anyway. Text editor, sure. Let's just have a look. See, where it's just a bunch of... So this is basically binary instructions that the processor can understand and that we cannot. But the point of an exe file is that it's self-contained. It contains those 9 things or 10 things that we saw there in the stack trace that said, I ran this, then 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 I ran this, which, so this is like call, I call this, I call that, I call that, I call the next thing, and then finally it calls our code. All of those calls, or the code for all of those calls, is embedded inside exe. So unlike, let's say, .NET Framework, that requires you to have the .NET Framework DLL in place, otherwise it won't run because it's referring to a bunch of stuff in there. Or in the case of JavaScript, you hand the browser source code and you say, here, browser, run this code. Or in case of Node, you would type Node JavaScript file name, and Node would run it. So Node, the executable Node, which is a node.exe, contains all the code that knows how to turn the JavaScript text into commands that the processor understands. Here, with an exe file, this is self-contained. So I can give you this exe file, and you'll also be able to run this on your Windows computer without any changes. You won't need anything else except for that. And presumably that is true. So let me just go and verify that. So if I go and open this Windows terminal again, and man, I keep forgetting and I keep closing this. Change directory C:/Rust. Oh, there's a recovery too. Rust. Hello world. And that was in target debug. So there's the Hello World exe. And you can see it's fairly big. It's 157,000 bytes. So it's not small for just printing out the Hello World. However, I can go Hello World. Oh, right. Except the way I've got my PowerShell set up, I actually need to say ./Hello World, and then it will execute. So there it goes. There's the Hello World. You can see it right there. Hello World. So this, and again, like I said, if I take this executable, copy it somewhere else on my computer, copy it to another computer, copy it to your computer, it's still going to work exactly the same way. So it's self-contained. So it requires nothing else except for that 157,000 bytes. And so for Hello World, that's kind of big. But for anything else, compared to the size of Node or compared to the size of .NET Framework, this is pretty small. All right. And so one of the advantages they claim is that we're going to get speedier code out of this. And so that's kind of one way of doing it, is to actually do the speedier code. All right. So let's see, what are we going to do? We are going to move to the, I guess we can move to the next lesson here. So let's go have a look. Let's go find back to the browser. And right, you keep collapsing and I don't want you to collapse. Okay, so there we go. We did this. Activity. Click run above to see the expected output. Add a new line on a second print line. Macro. So the macro? All right, let me, oh, here we go. Print line exclamation mark is a macro that prints text to the console. Okay, so statements here, what does this say? This is the main function. Print text to the console. Okay, so all right, so let's do that. Let's do their activity here. So again, if I'm going to go back to Visual Studio Code, and I'm going to add another print line. This is a second sentence. Okay, and if I run this, there it is. Hello world. This is a second sentence. So, whatever. All right, so what have we got here? Oh, look, this is kind of cool. If I hover over this, macro rules for print line prints the standard output with a new line. On all platforms, the new line is line feed character alone, no carriage return. The macro uses the same syntax as format, but writes the standard output instead. See standard format for more information. Print line macro will lock the standard output on each call if you call print line within a hot loop. Okay. So we're going to block. So this is something for the later. This behavior may be the bottleneck of the loop. So we may need to pay attention to that later. But for now, we'll just go, oh yeah, there's some weird thing where we might want to use write instead. Use print line only for the primary output of your program. Use ePrintLine instead to print error messages and progress messages. Interesting. Panics. Panics if writing to standard out fails. Okay, I wonder what a panic is. I'm assuming, so in C# and other Java and JavaScript, there's this idea of exceptions that get thrown if something goes wrong. I assume that panics is their terminology for exceptions. Could have just used the word exception, but I guess, kind of be cool. There we go. Oh, and look, there's some kind of format thing going on. Interesting. And we have local variables. So so if you're familiar with JavaScript, that should look really familiar. Let local variable equals sum. Okay, that's fine. We'll move on. We don't need to bash this. Don't show that again for exe files. Thanks very much. All right. No, we're good with those. All right, let's back to why do you keep doing that? I don't understand. Anyway, let's move on to lesson 2. Okay, comments. So you can, in the first one, there was all these double slashes, right? And if you're not familiar with, if you've never written any code before, then you go, why didn't it do any of that stuff? That's because that's how we do comments. And these comments are the same comments as C#, Java, C, C++, JavaScript. Pretty much everybody that started from that C root and kind of spread out, all those C-like languages, they all use the same kind of style for comments. I believe this also supports the /*/ comment approach. Back in the bad old days, when I was using a compiler back in 1983, C compiler, these were the only kind of comments. This thing is a more recent invention, the one-line comment. All comments had to be like this, which was, so when this came out, this was like a godsend. Because, oh my God, this is so great. The problem with these comments is that they're I think it says they're useful in temporarily disabling chunks of code. Block comments can be nested. Okay, so this is actually an innovation too. Block comments can be nested. In my experience, compilers were not always so good about that, and so we always tended towards using these when we were trying to comment out blocks of code. And these days, like in Visual Studio, for example, you can go in and you can select a range and say comment this out, and it'll do that. And it'll use these slashes to do that. All right. Anyway, so that's fine. Comments, document stuff. Oh, this is interesting here. This one's kind of cool though. The // generates library documents for the following item. So remember we had that extension that talked about being able to read comment or read documentation. This is how you generate documentation for that tool to find and display for you. So the // or the // with an exclamation mark, I guess both mean that. If you ever use Visual Studio in C#, the triple slash is the thing, right? Because I actually these days when I use Visual Studio, slash 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 gives me a whole block of comments, and it automatically looks at the parameter list of my the method that I'm on top of, and extracts that out, and puts in a bunch of stuff, spaces for me to fill in some comments. I'm assuming that's not going to be the case here, but let's find out. So if I go, and that's line 1, so I need to drop it down. So if I go slash slash slash, yeah, nothing fancy. Hello. This is my first. Oh, by the way, you may or may not have noticed I have an extension on here, the code spell checker. I would, if you don't use spell checking on your code, you really should. And it will check variable names too, which is kind of nice. This is my first Rust program. Okay, there we go. So save that. All right. All right, let's move on. What else have we got for us? All right, you know what? Let's close this one so that I can just go, give me that. There we go. Now it won't collapse. All right, formatted printing. All right, so we have printing is handled by a series of macros defined in standard format, some of which include format, print, print line, eprint, line. And by the way, I've been pronouncing it line, and it is, but ln may not be obvious to people that it's line, line. This, just as an aside, this is a standard short form for line, is ln, and back in the day, there was no code completion. Right? You'd have to type out the variable name or the function name in full every time. There was nobody to help you. So that's a lot of typing, man. So we got lazy, and we everything is short formed. Everything is, drop any vowel you can possibly drop, which is ln instead of line. Compress things down so you end up with these single character variable names and all that stuff. But you know what? These days, all the tools we have do all sorts of cool things on our behalf. So there's no reason to use short forms in your code. Obviously, we're going to have to use short forms because they are using short forms here. But we're going to have to kind of go with when you're creating your own variable names, use full words. It's better, and the spelling checker will like you too. All right, so let's copy this, and I'm going to bop over to let's see, Visual Studio Code, and in the terminal I'm going to say change directory. I'm going to go up one level. I'm going to say cargo new format. Right? So we're going to play with format. Is that what? Oh yeah, that's what we're doing. We're playing with format. Let's see. Just make sure. Formatted print. So how about we say instead we'll call it print formats. How's that? So we're going to create one of those. Okay, we've created the thing. So now what I want to do is I want to close this one up. And I'm going to say file, open folder, and print formats. Select folder. Okay, so now I've switched I am now, yeah, it's okay, cool. Thank you, GitLens, for letting me know. You can go away now. Okay, so now I've switched, and now this is back to, well, because every time I do this, it's going to create this thing. Oh, and it created a target. It's interesting. Did you see that? While we were watching, it created a target, which means that it's monitoring my thing. And when I open it in Visual Studio, it says, "Oh, you know what? Will want to run this. So let me just create it for you." All right, so I'm going to remove that and paste in the code I copied. Okay, so now we've got a bunch of stuff with format. So, I mean, there's no point in retyping code just for the hell of retyping code. We might as well just start with what they give us and start playing around with it and see what happens. All right, so let me just run this and see what kind of output we get. Oh, okay, so we have an error. All right, there's our first error. Invalid reference to positional argument 1. There is one argument. So now, okay, so this is a fairly common thing for compilers to do, and that is point out your stupid mistakes. In this particular case, it's saying my name is 0,1 space 0, and there's only one thing. So this would be probably index 0, and we need something at index 1. So my guess would be that, yeah, because it says here, positional arguments are 0 based. So it's probably, the way these things work typically is you have, you'll list a bunch of arguments, and then this will reference each of these numbers will reference a particular argument on the list of arguments to your print. So, we'll just go with that. So we need to fix that before we can run. So let's find that. And where'd it go? So it was, let's go back up here. Line 40. So let's scroll down to line 40. There it is. Oh, look, there's even a comment. Fix me. Add the missing argument, James. Okay, let's do that. Let's grab this string, copy, and we need a comma between them. So it's going to read Bond space James Bond. Okay, and see the error still persists because we haven't saved yet. See the circle up here? It indicates we haven't saved. So if I can do a Control S, that saves it, turns it green, and now my error goes away. And so now if I run this thing, there we go. It actually worked. Okay, so here we go. My name is Bond, James Bond, and then there's a bunch of ones and zeros here and whatever. Okay, cool. 31 days, whatever these mean. So let's go have a look and see what is going on. What's generating all these? So this says, so this will replace arguments. This will be automatically replaced by any arguments. These will be stringified. Okay, so that's kind of a fun word. Notice the spelling checker is okay with it. What it means is that anything that can be turned into a string will be turned into a string. So in C#, the one I'm most, in JavaScript, for example, well, yeah, in C# and in JavaScript, you can, so typically there's a toString method that you can attach to an object, or that is already attached to an object in C#, and you can override that and you can make it output whatever you want. By default, it outputs the name of the class, which is not particularly useful. So it's a similar kind of thing. It'll convert, but integers and floating point numbers, they have a built-in toString in them that turns them into strings, and with a kind of a standard format. So, a floating point number, you'll get, whatever point, whatever. you'll get, if you go with like integers, it's just the number, like that's an integer. Any complex objects, you have to provide your own conversion. So that's kind of what's going on here, is that they're taking this number 31, converting it into a string, the string 31, and then dumping it in here into the first pair of curly brackets, and then saying, okay, cool, there you go. And so then we get the 31 days right here. Okay. Positional arguments. So there was 0, 1, 1, 0. Bob, this is Alice. Alice, this is Bob. Bob, this is Alice. So that's 0, that's 1. Okay, and then we can use named arguments. Subject, verb, object. Okay, the lazy dog, the quick brown fox jumps over. So we can, kind of do that. That's cool. Different formatting. We can invoke by specifying the format character after a colon. So B gives you binary. Yeah, so we have the standard is base 10 with nothing. Binary, octal, hex lowercase, hex uppercase. All right. We can write justify text with a specified width. So a bunch of spaces and 1. So this is nice if you're displaying a column of numbers. You'd want to display that. You can do a fill with zeros, it looks like. And this arrow points to what you want to do. So this would be 0, and the angle, the angle bracket, extra zeros, left adjust by flipping the sign. This will output 1000. We put the 1 and then a bunch of zeros. Well, that's not very useful. Okay. I guess maybe I'm going to pad with zeros. And then you can use the named arguments if you append with $. So if you say width $, then you can say width equals 5. All right, that's interesting. That's kind of an unusual one. Okay, and then was that James Bond thing. And then we've got this. All right, then one more thing. We've got allow dead code. All right. And this will not compile because structure does not implement format display. Blah, blah. All right. We're going to, I guess, this is trying to show us something which we really don't understand at this point. All right, so we'll just ignore that for now. I'm sure they'll talk about it. So the one thing I did want to play around with is, so here, let me just scroll to the, scroll into the right place. I'm looking at this going, this is not the way I really want to display numbers, because columns of numbers should be right justified. So this one said, if I take that and just say shifted by, what if I do a colon, is it colon? Yeah, it was colon shift 20. So let's see what that does. Save that, and let's, where are you? Run. Okay, there we go. Oh, that's cool. We got a whole bunch, and then, I wonder. So, let's see. If I'm going to do this, let's see. Can I do that? Shift 1. No, it's not going to let me do that. 1, 2, 3, 4, 5. All right, so this is 4, 8, 12, 15, 16, 17, 18, 19. Okay, what, 20? So that, I guess what that means is this 20 doesn't mean 20 spaces. It means the whole thing should be 20 characters long. So let me kind of fiddle with that. And actually, so that means that I don't really need this anymore, right? Because if I say, because this is weird to do this formatting. Oops. It's weird to do this formatting here, honestly. I guess it's kind of cool that it lines up, but if I do the shift 20, then let's just save this and see what it does. Back to run. Okay, so then there we go. So 10 and then a bunch of spaces and then my 69420. Okay. All right. So I'm cool with that. Now let's see. I would like to do this as well. So can I do this? Shift 20B. Let's see if I save that. Am I going to get the right thing? Run. Oh yeah. Although it pushed it over by this many characters, right? So I actually kind of want what do I want here? I want, oh, you know what I want? I want this part to all be the same size. How am I going to do that? Okay, so what I want, yeah. I think what I want here is I want to, how am I going to do that? Okay, so I want to say shift this, colon, shift 20, and then I'm going to make this, all right, I'm going to make the first parameter base 10 colon, and then I'm going to get rid of this. So then the idea would be that instead of having like this and then have a hard-coded number of spaces, which then I have to go space when I wanted to change it, what I would do is I would create this thing and then pass in the string base 10 or base 2 or base 8 or base whatever, and do that. So let me just, so what I want to do then is I want to take this line 2, 3, 4, 5, right? So we have base 10, base 2. So I'm going to take this part and replace the 10, replace the 10, replace the 16, and replace, oh yeah, that's the same thing, so replace the 16. All right, and so now I don't need these anymore. All right, so now if I save that and run it, where'd you go? Up here, run. All right. Oh, okay. Oh, okay, that's interesting. So now I'm getting, I see. So I have here, now interestingly, what's happening, see how it's different? It's because this string is longer than 20 characters. So it's not going to truncate. So I was kind of hoping maybe it would truncate, but it doesn't. So the 20 says this is how big it should be, but if it's bigger than that, if this string is bigger than that, which it is by 2 characters it would appear, then print the whole thing anyway. So in other words, if I said, let's say 25, save that, and we're going to run that again. There, everything lines up. And so now I've got right justified this, and I've got right justified that. Now, maybe I don't want to right justify this. Maybe oh darn, I deleted all the binary octal stuff. So let me just go binary octal X and capital X. The reason this is I can do that is because that's pretty standard notation. X for hexadecimal, B for binary, and O for octal. Although Nobody uses octal. Nobody? I mean, very rarely does anybody use octal notation for anything anymore. You can ask what octal is if you want, but I'm not going to get into it. All right, so let's go back, run this again. All right, there we go. We're right justified. We're right justified. Everybody's in the right format. If we wanted this to be left justified, then I guess what he's saying is if we shift this that way, let's just make sure. I'll do one of them and run it. Yep, base 10. There we go. Base 10 all the way over there. So we can either go left justified labels, right justified numbers, or we can go right, depending on what we do. So let's just switch all of these over to the other direction. Now, you say, well, how is this any better? How is this any better than what we had originally? Well, one thing to notice is that, I mean, if we were doing this over and over again, because this is repeated, it means I can put it in a loop. Okay, we haven't talked about loops yet, and I'm sure, but we'll get to them because that's kind of a standard thing you can do in any language is a loop. But if you can structure the code so that it's amenable to loops, then so what we can do then is we've got an array of these things. The space in between is independent, and in fact what we could maybe do is we could write some code that says, okay, go find the maximum length of this and then add 2 characters, and then that's going to be the number that I put in here, because again we could do this thing here, this width, right? Now let's see, can we do that? So let's say, let's try that. Let width equals 25, and let's change this to width dollar. All right, let's just do one of them, see if that works. Run. Yeah, that worked. Okay, so that means that I don't actually have to hard code anything. I can just say, I can take this width thing, and again what it means is I don't have to retype this. I can change this one number up here and they're all going to change. So I can push it or pull it or whatever I want to do to it. I can make changes, and I can obviously so this would be an effect. And again, let's have a look. Do they have a variable? They have variables here. Yeah, there's number width. Okay, whatever. So this is going to be now. Yeah. So width label. Can I do a? Oh, so look at this. Variable W label should be snake case name, like W label, Rust Analyzer. Okay, quick fix. Quick fix. Rename to double label. Okay. So it really wants us to do this with the snake case style. Yes, boss. So when in Rome and all that. So that's the whoops. And our let width number equals 20. I'm curious about this one. So this one's obviously going to work. $. Right? So I'm going to save this and just make sure that this is working for me before I try the next thing. Yep, that's still working. Okay, let's replace this 20 with width number $, because I'm wondering about this $, immediately followed by the B, whether it's going to interpret this correctly or not. So save that. Ooh, look at the formatting. The line got too long and it broke it up. Okay. All right, so we'll run. And it still works. We've got a binary number here. Awesome. So here, this is the one thing I am not a big fan of, because this line got longer. And so, you know, we said, okay, cool, that line got longer, so let's break it up. But I've got this pattern going on here, and I'd really rather not break up the pattern, because it was so much easier to read, right, when it was stacked on top of one another. But that's okay. I guess that just says write a loop, buddy, and then you won't have to worry about it, because I'm basically just repeating everything over and over again. So let's save that, and there you go. Everybody's now shifted over. So the width of the number and the width of the label, and so label width, number width, and 20 and 25. So again, the key bit here is that I only need to change these 2 spots, and I'm going to get a new formatting. But so we can combine things, right? We combined this padding behavior with this the formatting behavior, which is cool. Okay. So there's the padding. We talked about the ret justifying. So that's 0. Oh, that's the one last thing maybe we could throw in. Instead of spaces, right, we can throw in zeros. And maybe we'll throw in a dash. Oh, no, that didn't work. What can we do here? I want to put in a character Q. Let's try that. Save that. What's this? What's your problem? Cannot find the value Q in this scope. Yeah, I know, because I want it to be like 0. Oh, no. Sorry. Never mind. It goes there. So Q. Right there. I was putting it in the wrong place. I was putting it over here on this side of the colon. I wanted, if I'm trying to put a padding character in, I want to put it on that side of the colon. So let me run this again. And there we go. There's my Q's for padding. And then I have one extra padding, which is, where'd it go? This character right here. And then a bunch of zeros, leading zeros, and then the number because of that 0. Now, so what that argues is, you really shouldn't have this, because every time I say it's going to be that wide, it's actually going to be that wide plus 1 character, and so then people are going to be scratching their heads going, I told it to be that many, why is it 1 more? And then they're going to have to find this spot and fix it. So don't put extra spaces in if you're doing this kind of business, because you're just going to mess people up. So Q is not the greatest, but maybe I could put, can I put a dot? Yeah, let's try that. All right. So yeah, there we go. So boom. Yeah, that's cool. Okay. So we can do all sorts of fun things with this. All right. My name is, and then we've got this new thing. So only types that implement format display can be, again, FMT stands for format, and that's pretty common that it would, and it's just dropping vowels, and I guess in this case the R as well. So that's, but again, it's kind of rooted in the idea that, hey, I have to type all this stuff. Let me not type so much because I'm lazy. Format display can be formatted with curly brackets. Use define types not implemented. Format display. Okay. So what this is saying is, hey, I've got a floating point 64. I've got a width that's usize, and then, right, we do this print line thing, which is like one. Excuse me. Okay. All right. Try uncommenting this line. Okay. This struct won't print. Structure 3. Okay. All right, we'll try. So there we go. Let's run this thing again. Oh, and there, crash. We got another error. Structure 3, structure cannot be formatted with the default formatter. So if you remember what I said not that long ago about C# and how you can have a toString attached to each of your objects, and so the default things, the simple things like integers and floating point numbers and strings, have a toString that's already defined that does the right thing, but that the toString of an object in C# will just display the name of the object. Well, a similar kind of thing is happening here, but in this case, we're getting an exception, because it's saying I don't have a default method for doing a toString on a structure, so I'm just going to tell you this is an error. And now it's up to you to define the code that will allow you to create this structure, or the toString of a structure. So I think at that point, what do we got? We're at 8:21. Okay, so let's do that one last thing, and then I'll be done for today. So let's go and have a look, because I think, I mean, they didn't put this in to just prove that we don't know how to write code and then leave. They must have provided some kind of assistance, right? So what's going on here? Okay, fix the issue above the C fix me. Okay, so we did. Try uncommenting the line that attempts to format the structure. C to do. Did it. Add a print line macro call that prints pi by controlling the number of decimal places shown for the purpose of the exercise. Okay. All right. All right. Let's see. Okay. So what's this? Standard format contains many traits which govern the display of text. The base form of 2 important ones is listed. Format debug uses the : marker. Format display uses the curly brackets. Here we use the format display. Okay. So what are you trying to tell me here? What are you trying to tell me? So this : thing to debug, I wonder, let's go back and try if, could we put : in here? : save that. Oh, I don't know. Structure does not implement debug. Oh, well, that's no fun. No, that didn't work. Oh, what was this? Consider annotating structure with derive debug. Ooh, okay, let's do that. Derive debug, or capital D debug, looks like. Okay, oh, now that error went away. Let's let's give that a whirl and see what we got. This struct won't print. Huh. Did it? Let's see. This struct won't print. Struct 3. Oh, but it did. In single quotes, backticks, inside the backticks, it put something. Structure 3. So it did. It did actually print this there. And it's kind of like the name, right? So it's like in C#, like I said, the objects get names that by default. So here, if we do the debug output, then it'll actually print the name of this object. Now this is kind of boring because this is 3, right? But I think if we were to do something like let value equals 7, let's do it that, and then we said structure value, and we'll run this again. And structure 7 won't print. Okay, so it is actually printing it's not printing this text directly. What it's printing is the fact that it's a struct and whatever the number is. So 7 in this case, because we did that. So this question mark, this colon question mark, allows us to print things that normally we wouldn't be able to print because they don't implement this format display, whatever this is. But by applying this, and notice it was called an attribute, right? So if we comment this out, home, then this is going to complain. And it's going to say, consider annotating structure with that. So the key word here is annotation. So, so this is a similar kind of concept to C# actually, where you have annotations, attributes. Actually, in C# they call them attributes that you can apply to things, and it even uses the square bracket syntax in C# to say this is an attribute that's to apply to the following piece of code. That's a little different because I need to go hash square bracket in Rust, but similar kind of thing, and they call it annotation instead of attribute, but okay. So I'm kind of getting the feel for it here. So we've got kind of some similar patterns. Okay, but so now we've got something that's printing successfully, debug style, so it's not pretty, but it puts something out, it doesn't throw an exception. So, that's not so bad. So there we go. We've got some code that works. And where we'll leave off then is, let's go back to the browser. So what do we got down here? We fixed the issue. We tried uncommenting. Oh, and one last thing. Add printline macro that prints pi. And controlling the decimal number of decimal places. Okay. So, and there's C also. And so this will link to some actual documentation. So there's something about struct, something about macros. So struct, yeah, we'll worry about that later. Let's see. Custom types. I bet you struct is in here. Probably. That seems to make sense because it's a custom type. And traits, we haven't talked about traits. I don't know what traits are. I didn't see traits in here. At least maybe I didn't think I saw traits. So I won't worry about it for now. But so this pi thing So if we say, so let's add one last thing here. So back to here. So let pi equals that. Print line exclamation mark curly brackets pi. Okay, so if we do that, let's just make sure this works first. And we're going to run. I really need to stop scrolling all the way up to get to run. Okay, there's our pi, but we don't have a very good number of digits. So we want, let's say we want 3 digits, or yeah, 3 digits of pi, 3.142, hopefully with some rounding. So typically, let's see. So if you want to do some formatting, it looks like it's, we need the colon character to say, hey, we want to do some formatting, right? Because we looked over here. There's like, it starts with colon and then some stuff. So I'm going to guess, because in C# and pretty much every other language, if you want to specify the number of decimal points, you just put in the number of decimal, like you put a decimal and the number of decimal points. So I wonder if that'll work here. Okay, one last time I'm going to scroll to the top. Run. Oh, look at that, it worked. So that's, you know. So this is a pretty common way of doing it. So the colon thing is a kind of unusual, but you know, it follows the same pattern. So we've got this, the pattern being curly brackets to specify a thing, and then inside the curly brackets, colon, anything after the colon is formatting instructions, and then we don't want to do padding in this particular case, yeah, okay, and then we have our the last character is the style. So okay, but I wonder if, let's see, can we combine some more stuff? Where is the here, right? 0 goes on the other side. Okay, so I want to, so I don't know how we do this. If I wanted to do 0, 3.3, let's see, what does that do? Because I'm thinking it might put padded 3 up to 3 zeros, so it would be 003.142 is what I'm hoping I'm going to get out of this. Nope, that didn't work. Okay, so yeah, or maybe I need the, do I need the angle bracket? Let's see, how does that work? Oh, hang on a second. All right, let's try that. Let's see. No, still didn't work. But what if this is not the number of digits before the decimal, but what if this is the total number of digits to display? So let's make that a 7 instead of a 3. So it would be like 3 digits dot, that's one more, and then 3 more digits, which is 7 altogether. So let's see if I try that and run that. Oh, still not. No, I'm just not going to get this. I may have to look that up. How do I make that happen? So that's kind of an interesting question. How do I make that happen? Or maybe, what about that? Oh, we have padding. 2 spaces and a 3. Okay. But the 0, we didn't get any zeros. Oh, but hang on. 0. I put it on the wrong side of the colon again. Darn. There we go. 0003.142. Awesome. Awesome. Okay. So, there we go. Some fun stuff. All right, and that's that. Thanks for watching. I'm going to move this up onto YouTube, and hopefully people see it there too. Bye.